Hello, everyone. Welcome to my presentation. My name is Szymon. I'm an MLOps engineer here at DeepSense AI, and I'll be talking about managing infrastructure with GitOps and ArgoCD. So on the agenda, we have a little reminder on CI/CD, what it is, how it works, and how it compares to a GitOps workflow. Then I'll tell you about what GitOps is. So I'll show two GitOps approaches with examples. And after that, I'll walk us through a demo that I prepared, where we are going to be using one of these approaches by installing ArgoCD and then using that service to make deployments to a Kubernetes cluster. So let's start with that reminder. So I think we all know basically what CI/CD pipelines are and how they work, but I'll go through that. So for CI, on each proposed change to a repository, we are running tests and checks on the code to just make sure that the functionality is still working correctly. Given that this process is fully automated, we can commit to doing small and frequent changes. And thanks to this granularity, we can easily track, fix, and roll back those changes to the code. Continuous delivery is the next step in the process. So if the CI pipeline run was successful and the changes are merged into the target branch, then we can go on with CD. And what we have here is basically testing and building some deployment artifact that we're interested in. It can basically be a Docker image that is then pushed to a Docker repository, or it can be a Python package, whatever. There is another CD, which is continuous deployment, and this process is comparable to continuous delivery, but it has an extra step where the pipeline does the actual deployment of this newly created artifact to some environment. And yeah, we are going to be talking primarily about continuous delivery in the scope of GitOps. And this CD goes hand in hand with CI, so also with small and frequent changes, because thanks to CD, they show up in production fast and can be either deployed, or if the deployment is automatic, in the case of continuous deployment, they can be used right away by the end users of the system. And what GitOps does basically is it applies those mechanisms for automatic checks and deployments to creating and managing infrastructure. So in more detail, what is GitOps? So it is a set of DevOps best practices that are normally used for the traditional app development that are applied to maintaining infrastructure and configuration using Git repositories. This repository serves as a single source of truth for this desired state of the infrastructure. So this is the only place that defines how the infrastructure should look like. In this repository, we keep declarative code that represent the states that we want to achieve. On an example, how does it work? Let's say we're working on a model serving web application. We've specified a application CI/CD pipeline that's responsible for building and testing the changes, along with building and pushing a Docker image where we've containerized the application along with the model. This is all the CI/CD that we just went through. So here we are creating a merge request with changes to the application code that triggers the aforementioned CI/CD pipeline. And here we are still in the scope of traditional CI/CD for app deployment, but here where GitOps comes in, and it's the intra CI/CD pipeline. So a step in the first pipeline, in the CD part of this pipeline, triggers a configuration change to our infrastructure repository, and this change can be set to be merged automatically after passing its checks. And then this change in configuration is observed by our agent. This is the GitOps tool in the diagram, and it works to automatically deploy the infrastructure changes based on what's the latest version of the code in the repository. And this whole deployment process is using Git as an entry point for making any changes to the environment. And this, of course, allows us to maintain this environment using the Git mechanism. So we have versioning, rollbacks, all the good stuff. To summarize, what are the benefits of GitOps? We have easy and automated infrastructure deployments. We have reduction of infrastructure drift. Because it's automated, we also have less room for human error, of course. And thanks to using Git, we have visibility and versioning for the infrastructure states that we are creating. And also we have fast recovery and rollbacks to any of those given states. And some of you might notice it may sound a lot like infrastructure as code, right? And that's correct, because this is one of the crucial parts of the GitOps workflow. But in order to achieve the whole GitOps approach, we have to pair that with keeping the code in immutable versions, so Git. And also we, with that, have some automations that apply those new changes to the environments. So for GitOps, there are basically two types of approaches, and we have the push approach and the pull approach. So the push approach is where the CD pipeline is triggered by an event such as a push to the main branch, for example, and then runs the deployment process based on those changes. And the pull approach is where a CD agent, a GitOps tool, is constantly monitoring the repository, pulling and comparing the changes with the current state of the environment that it's managing. And it's deploying the changes, basically reconciliates the states between what's represented right now in the Git repository and what's currently deployed in the environment. So a little bit a little more about push approach. It is much like a traditional CI/CD approach, but applied in the context of infrastructure. So we're going through the whole process again. We have some infrastructure as code. We are changing that, merging that. The CI pipeline completes, of course, and after merging, we can go into the CD part, which creates the whole deployment. And the example for that is deploying some Terraform code with GitHub Actions and AWS code pipeline. So for the CI part, we have a GitHub Actions CI pipeline that lints, formats, and runs the Terraform plan command for all the code that is changed. And after we have that passing and merged to the main branch of the project, and then we can go on to the CD part, which in this example is implemented in AWS code pipeline, which does basically the checking out of the latest version of the source code, and then running the steps of Terraform plan to account for the changes, to find out the changes that need to be made. We have approval step. So this is the last barrier where we can check out what the plan looks like and then manually approve it. And after that, the pipeline goes with the automatic deployment using Terraform apply. So why we should choose push? It's intuitive and well established because we are using the same CI/CD processes that are used in traditional app development. It's flexible. There is flexibility of the type of target environments because given that the CD pipeline is in most cases custom, we can target any type of deployment environment, and we have event-driven change detection. So there is no need for constant polling of the repository that we are observing. And the second approach is the pull approach. It's a newer approach for some chosen environments, primarily Kubernetes. And here a dedicated service, so a GitOps agent, in this case ArgoCD, periodically checks the current state of the repository, compares that with the state of the infrastructure in our deployment environment, and makes changes to this environment so that's in line with what's represented in Git. So this agent is typically working on the cluster that we are deploying to, and we are specifying the repository credentials if we're working with private repositories. And what we need to do is that we need to create an Argo application resource, Kubernetes resource. So thanks to that, we are registering which repositories should be observed by ArgoCD and what resources from these repositories should be deployed to our cluster. And when we do that, and when ArgoCD detects changes between the remote repository and the cluster state, it reconciles them so that they match, updating the resources and fixing any infrastructure drift that might have happened. So why should we choose pool? If we are running on Kubernetes, it's the off-shelf solution like ArgoCD. It's simple and effective. It has more features, but less flexibility typically than the push approach. And what's most important is that the agent is proactively looking for changes in the code repository. So it reacts to any changes that are made in the environment, in the cluster, and tries to reconcile them with what's represented in Git. And that, of course, makes for easier management of configuration drift. And the whole approach is typically more secure because the agent is often running inside the environment that it's targeting. So we're not using any external services that are trying to push something to our cluster. We are just contained inside the cluster. And this concludes the slides part of the presentation. And I prepared a little demo in which I will be installing ArgoCD on a local Minikube cluster, and then using that to deploy some services. This would be JupyterHub for running notebook servers. So here we have a repository with some demo code. We have Kubernetes resources, the JupyterHub.yaml and the AppOfApps.yaml files. And also we have a values file for customizing our JupyterHub deployment. And like I said, we are going to be running the demo on a Minikube cluster. So this is a local deployment of Kubernetes that is running inside a VM. It's very handy for development and, of course, demos. And we can see that the Minikube cluster is running. So we can go on with installation of ArgoCD. And for that, we are using a tool called Helm. And Helm is like a package manager for Kubernetes resources. We have collections of resources that are called charts that we can deploy and configure with our custom values. And those Helm charts have everything that they need to provide us with some full deployment of a service. In our case, it is now ArgoCD, and later it will be JupyterHub. So after that's installed, we have to make sure that we are having ArgoCD running in our cluster. So we are checking if all the pods of the service are running, and that is the case. So we can go on with first copying the password for the default admin login, and then we can create port forwarding to the ArgoCD service. So this basically allows us to access services that are running inside of our cluster by mapping the ports of the containers that are running inside the cluster to the local ports of our machine. So this makes the ArgoCD service available under port 8080. And we can go on to log in into the ArgoCD UI. So this is the landing page of ArgoCD. And here we can see all the applications that we are managing using Argo. And also we can create applications from hand. But we are going to be creating applications from the command line using the kubectl tool. But for that, we have to connect to our repository. So we can specify what repository we want to connect to. And I'm going to be specifying the demo repository. The username is optional, and we provide some password. And we can see that we are successfully connected to this repository. So now we can go on with creating an Argo app that will deploy JupyterHub for us. So this is how the resource looks like. It's its name and the namespace that it's going to be deployed in. And it's going to be deploying, of course, on our local cluster. And there are two parts to this application. First, it's going to be tracking changes in our private repository, where we keep the configuration for the Helm chart, for the Jupyter Helm chart. And the second part is the public Helm chart provided by the creators of JupyterHub that we can use to install the service. So we can go on with the installation of the Argo application. So that's done. And now when we go back to ArgoCD UI, we can see that we have the deployment present. And if we go into that deployment, then we can see that all the resources that are needed are deployed by ArgoCD. And this view into the deployment is very handy because we can easily see the status and the state of our resources. So it's easy to monitor for any faults and errors. We can even set up notifications to, for example, email or Slack, or collect metrics from ArgoCD to build more complex views and dashboard. Argo allows for a lot. It has a lot of features. It also allows for checking the logs of the pods that are deployed in our cluster. But right now, we have the service deployed. So we can also do the port forwarding to the JupyterHub service, and now we can access it. So here it is, JupyterHub that is going to be providing us with the notebook servers for every user that is logging in. And yeah, that's what's currently happening. We're creating a notebook server for the default user. So right now, ArgoCD basically automated the whole deployment of the service for us. And yeah, let's check if it's working. Let's run some basic command. Right. So let's go on with closing this notebook server, because the next thing we are going to do is we are going to make some changes to the deployment using the GitOps approach. So for these changes that we have, I'm going to be updating the customization values that we have specified in our repository. And those changes will basically consist of providing some additional profiles that the user of JupyterHub can access to create some different notebooks. Sorry, not notebooks, but notebook servers. So we can go on with the merging of this code. And of course, after that's done, ArgoCD will pick up on those changes and deploy them. The polling rate is customizable. It's by default takes a minute or two. but we can just click refresh to make ArgoCD pull the latest changes from our repository, and it detects that it's out of sync with that repository, and it's going to be automatically syncing the changes that are represented there with our environment. So it's applying this whole new configuration that we just provided. This, of course, warrants the rebuild of the services. So we can see that the ports just were deleted, and we are creating some new ones. And yeah, after that's done and the service is healthy, we can go back to the deployment. But first, we have to refresh the port forwarding just in case, so we can access JupyterHub. And after we do that, we can refresh the page. Of course, we have to log in again because we just restarted the whole service. But when that's done, we can try to start some server, and now we can see that we have some new options. So basically, the changes that we merged into Git are automatically deployed to our environment, to our cluster. And we have some other view that came with that deployment. So we can stop that. And maybe you're wondering, okay, but it's just a single app. It's just JupyterHub. Do we have to create those ArgoCD applications for every service that we want to manage? Yeah, you could do that, but there's a better approach. Basically, what we can do is we can create an ArgoCD application that will manage other ArgoCD applications. So we're not focusing on this approach of applying the resources by hand. We are just going to do this once for the AppOfApps resource. And what this resource does, it basically observes one path in our repository where we can put Kubernetes resources, and it's going to be creating those resources automatically. And these resources can, of course, be other ArgoCD applications. So this is exactly what this configuration says. So we have to create the Argo apps directory, and we are going to put the JupyterHub ArgoCD application into that directory. And after that, we can go on with the deployment of the AppOfApps app. But first, let's delete the old deployment of JupyterHub. So we are sure that we are having this new deployment managed by our new app. And when we do that, we can create the AppOfApps resource, and it should show up almost immediately in our ArgoCD UI. And there it is. But there's a problem with it, of course, because we didn't commit the changes, so adding the JupyterHub manifest to the Argo apps directory. So we, of course, have to commit those changes. So that's the status of those changes. If it's staged, okay, it is. So we can go on with the commit. When that's done, of course, we are going to be pushing those changes to the repository. And again, if we give it enough time, ArgoCD will pick up on those changes. But once again, I'll be just refreshing the application so it grabs the newest version of the code. And as you can see, we have the JupyterHub application here that is now managed by ArgoCD. And we can see that the deployment of JupyterHub is going the same as before, but now this app is managed by the umbrella AppOfApps. Yep. So when you have that, we can go back to the port forwarding, because we, of course, restarted the service. And let's check one last time if our deployment works correctly. And that's right. We can log into the JupyterHub. So it's basically the same as we had before, but now it's managed differently. And what this allows us is that we don't have to create any more ArgoCD applications by hand. We can just commit them to the repository, and the AppOfApps will be automating the deployment of them. So we are now fully off the hook with manual deployments. And the last thing I wanted to show you, a little feature of ArgoCD. It's called self-healing. It's enabled for all our applications right now. And what it allows is basically, let's say someone is working on the cluster and deletes some of the resources that are managed by ArgoCD. ArgoCD can recognize that situation and restore any deleted resources, so that the application and the release is working correctly. So here I deleted the hub deployment, and it's restored. And because we are managing the whole JupyterHub app with AppOfApps, we can even delete this whole deployment, and it should be restored by the self-healing feature. So this is what helps us with maintaining configuration drift and managing it and minimizing it as much as we can. Yeah, and basically we are having the same deployment as before. So even after deleting it, it all goes back to the state in which the whole deployment is working correctly. So that's it for the demo. Let's move on to some conclusions. Let's go there. So in my humble opinion, GitOps is very nice, and it's, of course, worth using because it has a lot of good things. It provides us with automation and with simplicity, security, and robustness for managing deployments. We are using the single source of truth approach for the infrastructure. So we're having infra code configuration to it, anything that pertains to infrastructure managed in Git. And because of that, of course, Git is the single interface for making changes to the infrastructure. And we have a lot of cool tooling for automating deployments. For push approach, we have the standard CI/CD tooling like GitHub Actions, GitLab CI/CD, and Jenkins, of course. And for the pull approach, we have tools like the ArgoCD I just showed, or FluxCD. If there are any questions, feel free to ask them now, and I'll, of course, answer. I'll take that as a no. So thank you very much for your attention, and see you soon.